You're listening to Peaks to Power, a podcast by the U.S. Department of Energy's National Laboratory of the Rockies. I'm Taylor Mankle.
And I'm Karen Jerriman.
Do you hear that, Karen?
I do. It's like a hum of some sort. It sounds like a fan or a refrigerator, something like that.
Yeah, close. That is actually the sound of the technology at the center of today's Lab Notes episode. It's a heat pump.
Oh, yes, I should have guessed. Heat pumps are everywhere these days. They keep our refrigerators and freezers running. They power window air conditioners. They can cool off our data centers. And they're also a source of heating and cooling in American homes. So before we jump into today's show, let's level set. Taylor, can you explain to our listeners what exactly is a heat pump?
Yeah, sure thing. A heat pump uses a refrigeration cycle to move heat from one place to another. Your window air conditioner, for instance, is a great example. It has coils filled with refrigerant gas, which absorbs heat from your home in the summer, and is compressed, which raises the heat and pressure. This hot, pressurized gas flows into another set of coils outdoors and gives off its heat, keeping the living area nice and cool.
Perfect. All right. A mini split air source heat pump does the same thing, absorbing heat and pumping it outdoors, except it has one bonus. By simply pushing a button, reversing a valve, you can change the direction of the heat flow, using it to heat your home in the winter and cool your home in the summer.
Now, a big benefit of heat pumps is that they can be paired with another system, such as an oil boiler or propane furnace, to allow homeowners to switch to fuel heating if the heat pump can't keep up with demand.
These are some of the ways heat pumps can add reliability and cut costs for consumers, something that laboratory researchers have in mind as they work to better this technology.
Now that's important because these appliances have become more common in U.S. homes in recent years. But there's a problem. Because heat pumps contain refrigerant, they have to be installed carefully by a licensed HVAC technician who can handle the chemicals safely, which means we need more trained professionals.
Yes, indeed. And to pick it up from here and explain how the National Laboratory of the Rockies is supporting this growing workforce need and helping make this technology more affordable, we welcome in Molly Rettig. Molly is the communications lead for the lab's Alaska campus and our guest host today. Welcome, Molly.
Molly works with a team who researches and develops heat pump technology. Molly, we are glad to have you on the podcast today.
Thanks. Glad to be here to add some perspective to this topic.
We're so glad to have you. First, could you tell us what people like about heat pumps?
Well, we talked to a lot of consumers in Alaska who are getting heat pumps, and for a few key reasons. First, they like having an alternative to oil or natural gas for heating. Because heat pumps are electric, they require no combustion inside the home. And second, heat pumps provide cooling in addition to heating, so it's kind of a two-for-one device.
Yes, they do. In fact, my current home has a heat pump installed, so I've seen how they work firsthand. All right, Molly, can you tell us more about their use in American homes and how widespread they are?
Sure, Karen. They may seem new because they're growing so fast, but heat pumps have actually been around for decades. If you grew up in the southern U.S. in the 1970s and 80s, you may have had a heat pump in your home. Now that they're getting more efficient in colder climates, we're seeing a growth in the northern United States. That includes Alaska, as well as the Northeast and Northwest. I spoke with John Winkler, a senior researcher at the lab who's been studying heat pumps for over a decade, and he explains this trend a bit more.
Both of those regions of the country, homes typically weren't constructed with air conditioning. And, if a home was built with like hydronic heating or electric baseboard heating and it lacks an air distribution system, it lacks ductwork, then mini splits could be a good fit for that home. And so we see a lot of those homes kind of in the Northeast and the Northwest. And so the heat pump market there has been growing pretty steadily for quite a while now.
So, Molly, John Winkler was actually one of the researchers at the National Laboratory of the Rockies who invented a technology to make the installation of heat pumps easier, right?
That's right. It's called EcoSnap. Snap, like snap your fingers. EcoSnap is a technology that bundles refrigerant and electrical lines into an innovative snap-together piece connecting the indoor and outdoor units, enabling contractors to install heat pumps without handling refrigerant during installation. This can even open things up for really savvy DIYers.
Ooh, and it's helping the energy workforce to manage this influx of interest in adding mini splits. How did it all begin?
It's an interesting story that actually begins not with heating but with air conditioning. 12 years ago, Winkler and his colleague Chuck Booten, also a senior researcher at the National Laboratory of the Rockies, were measuring the performance of window air conditioners, the main source of cooling for most American homes. At the time, mini splits were new on the US market. Although they were far more efficient than window air conditioners, they were also way more expensive and more complicated to install. In other words, not as simple as a homeowner lifting a box into the window. The two researchers had an idea. If they could make it easier to install mini splits, it could bring down the cost and make the technology accessible to more consumers.
So after doing some brainstorming and things, we kind of came up with this EcoSnap heat pump concept, which was basically an easy way to install a heat pump, kind of take all the specific skills out of the equation and allow people to install them on their own. The concept that we patented was more like the integration of the indoor and outdoor units, and having kind of a simplified process to deal with the mechanical mounting of the unit, and then not only making refrigerant line connections, but also making the electrical connection. And so EcoSnap is powered from an indoor receptacle similar to like a window air conditioner. And so the EcoSnap connector really makes it easy for the installer in terms of making all the electrical connections.
Okay, so fast forward 10 years, through a number of patents and awards, and they had a prototype ready to roll out. Researchers tested the EcoSnap technology at our lab in Fairbanks, Alaska, where heat pumps are taking off. All right, Molly, talk more about this project and what we learned.
The goal is to get this technology into the marketplace and allow a broader group of people to install heat pumps. First, we want to make sure it's actually as easy as we think. So last summer, we had an installer training at the lab's Alaska campus where we invited people from all backgrounds to practice installing the system. Over the course of the summer, 24 people came into the lab to give it a shot.
Molly, you followed along as participants drilled holes, mounted parts, and connected lines. Why don't you take it from here and tell all of us more about that experience?
A contractor threads a bundle of refrigeration and electrical lines through a hole in the wall and connects them to their counterparts in a box fan-sized unit. When locked into place, they pull a lever.
Beautiful.
That was the sound of a mini-split air source heat pump being installed. Not by a licensed contractor, which is who would typically have to install the device, but by a homeowner who has no professional HVAC experience. Robin Thomas participated in the program because she's interested in installing a heat pump in her own home one day.
I don't have a place right now that would be suitable for something like this, but eventually in life, I think it's a great, really efficient way to, cool and heat a home.
While Robin is pretty handy and performs regular maintenance on her car and cabin, she was surprised how easy the install was with the EcoSnap connection.
I think just all those connections, I wasn't sure how precise they need to be, but they're all very just they fit together, and then there's a clamp and it just goes in. I wasn't sure how technical that part would be, and it was really straightforward, so that was really good to see.
While super savvy DIYers like Robin may be able to install this on their own, EcoSnap can also be an option for a broader group of contractors. Rich Music has been installing HVAC equipment into homes in Fairbanks for 20 years, but has never installed a heat pump before. Recently, he's been getting so many requests to install mini splits that he decided to expand his business to focus on heat pumps. As he mounts brackets to the wall, Music explains where this demand is coming from.
It's mostly air conditioning right now, especially when it gets smoky out in the summertime.
Though it was his first time, it didn't take him long to mount the brackets to the wall, set the indoor and outdoor units in place, and snap the EcoSnap connector together.
If it's a pre-charged and sealed system, and all the line sets are filled, that's a lot of times the hardest part, is you have to pressure test, evacuate, and purge the line sets. But if they're already come full and it's just a quick connection, then what could possibly go wrong?
The goal of EcoSnap isn't just enabling a new set of contractors to support the heat pump field. It also makes the job faster. Instead of spending hours running electrical lines and making refrigerant connections, a contractor only has to mount the hardware and connect one line. Here, John Winkler, the inventor of the system, describes how that could benefit the workforce.
I think one of the main advantages that we see with EcoSnap-enabled heat pumps is that rather than taking a full day to install a heat pump, a contractor could do 2 or 3 EcoSnap-enabled heat pumps per day, because we've taken a lot of the steps that are typically done in the field, like making refrigerant connections, pulling a vacuum, running electrical, things like that. Those are typically done in the field, and we've moved those steps to the factory. And so that means that the time on site that a contractor spends installing these units has been significantly decreased.
After participants finished installing heat pumps, they spoke to researchers about which steps of the process were easy and which could use improvement.
How difficult was aligning the EcoSnap components? What parts of the aligning process gave you difficulty?
Well, yeah, we had just getting it to lie flush and level. I think having multiple people for that is important. So we just kind of worked through that until it was in the right spot. I think sometimes in the instructions here it would just say, now put it on, or I forget exactly what it said, but it could maybe say something like, there are little grooves that you need to line up, or, here's what you should be looking for.
All of this feedback was summarized by our team and turned into a list of design recommendations. So when a private company licenses this technology and brings EcoSnap to market, more Americans, be they DIYers or contractors, can get heat pumps into the homes that want them.
What a great exercise up in Fairbanks to put research that started in the lab into the hands of the people.
Yeah, it is really so exciting when we get to see the results that started here at the lab directly impact communities.
Molly joins us again now. Molly, that sounds like a really great experience you got to be a part of. Tell us what else your team is doing at the Alaska campus when it comes to heat pumps.
We've been doing a lot. We've been testing heat pumps in extreme temperatures to figure out how they can manage defrost cycle without creating too much frost on the coils. We actually just finished evaluating a new mini split that can operate down to minus 31 degrees Fahrenheit. This is a heat pump that's slated to be installed in 800 homes across the Arctic to help lower costs and keep homeowners warm. And we're also working in Southeast Alaska to assist local groups with deploying up to 6,000 heat pumps in a place that gets all its power from hydro. Like all the work at the National Laboratory of the Rockies, it's not just about advancing the technology itself, but also making sure it's affordable for manufacturers, ready for grid conditions, and offers an effective option for consumers.
Tons of growth in this technology and interest in the work the lab is doing. Molly, it's been a pleasure having you for today's episode. I've loved getting this deeper dive into such an emerging technology. To find out more, visit nlr.gov and search for the Alaska campus, or email John Winkler, WINKLER, at nlr.gov to get involved.
Thanks to our special guests for this episode, John Winkler, Robin Thomas, and Rich Music for their insights. And of course, a very special thanks to our guest host, Molly Reddick. Molly, it was great having you on the show today.
Thanks so much for having me.
And thank you all for listening. If you like what you hear or want more, please rate the show or send us an email at podcasts@nlr.gov.
Until next time, listeners.
This episode was written by Molly Reddick, Karen Jerriman, and myself, Taylor Mankel, with support from the Lab's podcast team. Our theme music is written and performed by Chuck Kernick, Jim Riley, and Mark Sanseverino of Drift BC, and episode music by Ted Vaca. This podcast is produced by the National Laboratory of the Rockies Communications Office.